Hello, everybody. Thank you so much for joining today's webinar. It's on our VectorPro software, and we've just entitled it VectorPro, the ultimate platform for force and materials testing. And before we get started, I just want to go over a few things. So this is a McMesson webinar. McMesson is part of the Physical Properties Testers, or PPT group. And the PPT group is a family of brands, all of whom are experts in the design and production of physical properties testing solutions. These solutions cover a range of physical properties, including tensile and compressive testing, torque testing, textile analysis, and real-world dynamics, such as shock and vibration. And then the other companies within the PPT family are Lansmont Corporation, James Hill, and Tailor. If you're interested in learning more about these divisions, you can visit our events page and see the content and on-demand webinars they have available. I've already put a link in the chat box, so you might have seen it already, or you might want to look at it after the webinar, which is fine. But back to McMesson, we have a technology lab located in Sterling, Virginia, and Slinfold in the United Kingdom. We established these labs as a way to support our customers through education, proof of concept, and testing demos. So please reach out to us if you have any particular physical properties testing needs, because we've got a global team that can support you. I want to introduce some people on today's call. Moses DeRocha and Carl Bramley are our presenters for today, and my name is Sharon Smorenberg, and I'm one of the organizers. We also have various support staff throughout the United States, Europe, and Asia. So if you need information or support, we have somebody that can assist in your region. And last but not least, we do want to keep this interactive, so please feel free to ask questions. You can use the question box throughout the webinar to type in any questions that you may have. We will then address these questions at the end of the webinar. This webinar is going to be recorded, so you will get a copy of the recording to the email that you registered with. And if you want to review anything for additional clarity, or if you have a colleague who is interested in attending but wasn't able to make it, please feel free to pass this recording along to them. And with that, I will turn it over to Carl.
Thanks, Sharon. You can all see me and hear me. What we're looking at to do today, or the purpose of this webinar, is to look at our existing Emperor software, which has been around for many years, and our newish VectorPro software, which has been designed to run on the Omnitest range of force and torque machines. And the improvements that we're making on the user interface, using the software and its functionality. And VectorPro is enabling us to maintain and develop our machine electronics as they progress, and also with the Windows operating systems getting updated quite frequently, we want to make sure that we're future-proofing testing requirements. So what we're going to do today is we're going to look at the Emperor and then VectorPro and backwards and forwards between different tests, and see how you can do it in both softwares and see how easy it is in VectorPro. I think we're going to look at tensile, a compression, and a bending test. And Moses will be showing the Emperor, and I'll be looking at the VectorPro and some of the features on there. So without further ado, I'll hand you over to Moses, who will look at the first Emperor section.
Thanks, Carl. So again, as Carl just mentioned, we have used our legacy Emperor software for a little over 20 years. And we've had growing needs and requirements and other testing parameters we wanted to look at. So that essentially led to the development of the VectorPro software, which, according to me and many of our happy end users, is a much more superior software in the vast capabilities it has to handle both force and materials testing applications. My job today is to kind of give you a quick glimpse into what we've done over the last 20+ years and how we've made that better, which Carl was going to do as well. So without further ado, as Carl mentioned, we will be looking at 3 major types of tests. First, a simple tensile test, and then a simple compression test, and then a 3-point bend test. So can you confirm that you all can see my screen, Sharon?
Yes, we can. Thanks, Moses.
Excellent. Okay, very good. So our Emperor software was designed to be a simple and complex, depending on what your application requirements are. Simple to use for simple applications and for complex applications in push or pull. Now there is another version of it that does torque, but that's essentially not today's topic. So we'll be looking at tensile, compression, and 3-point bend testing, which, if you think about it, most applications will fall under one of these 3 umbrellas. Tensile testing can be peel, it can be just pull to break. Compression testing can be push out, penetration testing, sharpness, compressive shear, and so on. And then there's obviously 3-point bend and flexure testing, which we will all look at. So if you have any legacy type testing program or productivity program, this interface will look familiar as far as starting a new test or start opening an existing test and so on. Most of the time, any test application, whether you're testing to a specific testing standard like an ASTM standard or an ISO standard or a mil spec, starts with whatever your preferences are. We'll start in our setup and the preferences. Now, I'll go over this in general, and then when it comes to the specific testing applications, I'll kind of speed it up a little bit because we've already looked at all of the different preferences. They don't pretty much change. So now in the preferences, this is where you select your type of test. As far as the software is concerned, it essentially represents the initial direction of movement, whether anytime you hit that start button to start a test, does it start moving up or does it start going down? So upstroke or downstroke, that represents tension or compression. So for tensile test, obviously that's going to be a tension test or tensile test. And the next thing you'll select are your units, preferred units of measurements. Most of the time, it could be newtons, could be pounds of force, kilograms of force, ounces of force, and so on. For purposes of our webinar today, we'll simply use newtons, and our displacement units will be either millimeters or inches. There are also time units, which are in hours, minutes, or seconds. So for those applications that might require a pull to a specific load and then holding for a certain period of time, if you wanted to hold it for hours, then it makes sense to select hours as your preferred time unit. If you wanted to hold it for a certain amount of time in seconds, then it makes sense to select seconds. Now, because most all of our testers plug and play with different load cell capacities on the lower ranges, all of these limits are usually automatically assigned depending on your test setup. So for example, if you have 1,000 Newton load cell attached to your tester, once you start the software and you log in, it will show what the capacity of the load cell is. These are all the assignments based on the type of tester that's being used, whether it's a 2.5 kilonewton tester or it's a 50 kilonewton tester and so on. The next thing we will look at is your home position, as in where do you want to start the test. So for most test applications, it's going to be a relative zero position, which is wherever it is. That way, if you have a 4-inch long sample or you have a 6-inch long sample, you start wherever you need to, just so the crosshead on the fixtures can return to that same position once the test is completed, and that enables the operator to remove the tested sample and then insert a new sample and so on. So we'll just enter 0. And then the home speed refers to how fast you want that crosshead to return to that starting position at the end of the test. Now, it makes a difference if you're testing just a dozen samples or you're testing 300 samples. Obviously, the faster the speed, the faster you can return the crosshead home, so you can test all your existing batch of test samples. So this is essentially all you'll do in the general preferences. There's also one setting that we usually prefer to use, which is the autosave. This feature allowed you to autosave your tests as soon as each test completed. That way you don't lose any data. in case there is some, Windows update or you lose power or whatever the case may be. There's a catastrophic event that kind of shuts your system off. Worst case scenario is you might lose the very last sample. You were in the process of testing, but then everything prior to that would have already been automatically saved. The graph settings allow you to kind of determine what your graph is going to look like as far as your X and Y. So for example, your X-axis is going to be your deflection or displacement or position or extension, and your Y-axis is going to be your force or load, whatever you want to call that. And then you have other options like grid lines. That's personal preference. Prefer graphs in your lines in your graph. There is an auto scale feature that auto scales the graph as well. These legends, there is an overlay feature in the Emperor that allowed you to overlay up to 8 samples, so you can kind of visually tell how consistent your tests were. So the legends pretty much indicate which colors represent which samples on your graph. So you can also check that box to activate it. There are also options for you between your X and Y, whether it was going to be a load versus displacement curve, or a load versus time, or a displacement versus time, or you can just select the others and choose your own inverted XY or YX, however you wanted to do that. The automate feature determines what happens at the end of the test. Now remember, you can set a data acquisition rate or sampling rate of say 1,000 hertz, 1,000 samples per second. So sometimes some of our end users prefer to do a reverse run. So for example, run at 10 inches per minute to a known displacement and then run at negative 10 inches back to 0. What happens then is, if the test actually completes on the first run, that reverse run continues data acquisition. So imagine it taking 30 seconds to return to 0. That's essentially 30,000 data points, which you didn't need to begin with. However, if you use the return home option, then the test actually completes on that initial part of the run, and then that return home, there's no data acquisition, so you don't have bloated data. So that's what that command represented. And then the results display was always going to be based on your selected calculations, whether you selected your peak calculation, average calculation, your slope, your known values at displacements or known values at a specific load, and so on. And you had options for choosing to display either just this current sample, which means only one sample would be displayed at all times right above that graph area, or you can display all your samples, whether it's 10 or 15 or 150. And you can also, once you select all samples, you can also display those samples in reverse order. So they're displayed in the order, not necessarily in the order in which they're tested, but then the last sample tested shows up first, and so on. And then finally, the next tab is where you select your data acquisition rate. If it's a test that takes longer to complete, especially when you're running at a slow rate of speed, then obviously you want to select a slower rate, sampling rate. Because as I said, if you took a 30-second test, the difference between 10 hertz and 1,000 hertz is whether you only collected 300 data points or 30,000 data points. So this is where the user selects the sampling rate. Once all these preferences are done, the operator can now go into test, select program, and then select a combination of these preset commands to create the actual testing procedure, whether it's a specific ASTM test or ISO test, or it's your own in-house custom test. A combination of these will put together a simple testing procedure. So when you click that start button, depending on what you put in those arguments, that's exactly how the test is going to run from start to finish. So most tests will usually have 0 command, and the reason for that is part of the process of fixturing your sample might create some residual load on your load cell, or you might have to move the crosshead up and down, have some residual displacement. Because you're not looking to transfer either of those 2 values into your test, it makes sense to tear both of those values out. And that's what that 0 command does. And that's essentially saying you're not relying on the operator to remember to manually tear the load and then tear displacement. Those are actually commands in that task bar. However, if you just write it into the command, then all they have to do is just hit the start button. They don't have to actually go to remember, because that could impact the test. So once you select the 0, the additional parameters, you can choose either just the load, tear just the displacement, or both. In this case, we'll just tear both and click append, and that command goes to line 1. The next thing we will do is to clear data, which clears the graph of any data or noise. That way we can have a clean graph to begin with. That goes on line 2. And the next command is the run command. Now, the run command is always going to be the brain of every operation or any test application, because this is where you determine first and foremost how fast the test is going to run, whether you're running to a specific force, or you're running to a specific displacement, or you're running until a specific amount of time has passed, or you're running until the sample fails, or sometimes all of the above, whichever comes first. So for purposes of our demo, we're going to run at 10 inches per minute, and we're going to run to a displacement of, say, 6 inches. Now, we know that in this tensile test, the sample is also more than likely to break before it gets to 6 inches. In that case, we will enter a break percentage drop here of 25%. Now, what this represents is when the load cell detects a drop of the applied load at least 25%, it's going to stop the test whether you've made it to your target displacement of 6 inches or not. So let's just say when you start pulling on the sample in your tensile test and you incrementally going up and you get to 100 pounds or 100 newtons, if the load cell detects the load to drop down to at least 75 newtons, it's going to consider that a sample failure or a break and stop the test, whether it's made it to 6 inches or not. That break could occur at the first inch, so to 2 inches, 3 inches, whatever the case may be. As soon as that drop in the load is detected, the test will complete, and then you'll be able to capture the peak at break and record that. And this number can be anywhere from 5% up to 95%. Question usually comes up as to when do you select 5 and when do you select 95. So if it's a more of a graduated break, think of pulling on a rubber band, it's not going to snap, right? It's going to stretch and then start thinning out and start tearing before it finally breaks. So you need a little bit more sensitivity in the capture. Whereas if you're pulling on a stainless steel rod, when it snaps, it's likely going to drop from that 100 pounds or 100 newtons down to probably at least 5 newtons or all the way down to 0. In that case, you would use a higher value like 75% or 90% drop to capture that break if and when that actually occurs. So we're going to click append. That throws that in the line of programming. And then finally, we're going to select the end command and then throw that in there. So this is a very typical, simple pull to break test. That's good for several different testing applications, whether you're testing rubber, plastics, soft metals, you name it. This is a very simple test that will do it, where it's pulling at a specific speed and pulling to a specific displacement or break, whichever comes first. Obviously, if it makes it to your target displacement without breaking, then that's probably what you're looking for. It's a strong sample, so that's good. So this is essentially the test, which completes step 2 of the process. We've determined the preferences, we've designed or configured the test. The final step, you click OK. Final step is to query the data that we just acquired to go into test, and then this time select calculation as to what kind of data are we looking for in this test. So in our case, most of the time we want to capture the peak force, which is the highest force in the test before the sample failed, or the highest force when we made it to that target displacement. So the peak force, again, we'll just call this break force. So you can call it max, you can call it peak. And then we'll also select an order of 0. And the way that worked in the Emperor software is, imagine if you had to crush aspirin, an aspirin pill, you'll get a bunch of spikes on your graph. If you wanted to capture the order in which all of those peaks occurred, you can use an order of 1, order of 2, order of 3 to essentially determine the order of each peak in your graph. So using 0 kind of toggles that function off and just select one peak, the highest peak at any point in the test from start to finish. In that peak calculation, you can also apply pass or fail criteria by checking that verify result box and then entering your minimum or maximum load. So any result that falls within that range is going to show up in green and have a pass, And any result that either falls below your minimum or goes above your maximum is going to show up in red as a failed sample. So instantly, as soon as each test completes, as long as you've applied pass-fail criteria, you should be able to tell whether the sample passed or failed based on your own internal requirements for what's good and what's not. So for now, I'll just uncheck that, click append. There's several other calculations you can get. You can throw in an average calculation. So we have the peak, but what was the average force across the entire test? You can capture an average force, and again, you can uniquely name that. And even that calculation can also be run through pass or fail criteria. And then finally, you can just throw in a time and date stamp of when the test started or when the test completed. And this is a typical tensile pull to break test where you're just looking to measure a break force. Once that entire test is configured, the next thing you do is go into File, save the library program, and we'll just call this our webinar tensile, and then save the test. So what happens then is for all future testing, all the operator has to do when they log in is go into File, load library program, which is going to load this program. They'll put the sample in and just hit that start button, and that immediately starts the test. And then once you generate your results, you should see, especially when you have pass or fail criteria applied, you'll see what's passing and what's not. So this is essentially how we went about configuring a simple tensile test in the Emperor software. And with that, I will turn it over back to Carl to walk you through the magic of VectorPro. Back to you, Carl.
Thanks, Moses. Hopefully you can see my screen now. This is, am I okay on this, Sharon? You can see my screen?
Yes.
Good. Okay, what we're looking at here is VectorPro. You can see that it's very, very different from what Moses just showed with the Emperor software. We've gone for a more visual, simplified, less programming. Emperor required you to do some programming there to create your tests. And we've also put in a lot of new features as well, because we're not just doing product testing, we're doing materials testing also. So features that we've put in here, which are quite important to a lot of people, particularly those in the pharma industry. You can see we've got all these tiles on our workspace here. Each one of these has a function. We look at our permissions tile. Now this is going to give you enhanced security for all your users and user groups. So here you can set up your password strengths. We haven't made it mandatory. It's optional for all users, but you can turn on the functions when you need them for longer character, uppercase, lowercase passwords. We've also got things like aging, so it'll force a password change after a period of time, locking people out after failed attempts. And then if you leave your workstation idle for a period of time, it will log you out and you'll have to log in when you come back. But also down here, we've got two other features here, which is our Active Directory. So if you would rather have your IT control access to the software through their Active Directory system, then you can activate that and link it. And that will be your domain logons to the software as you would in your normal IT infrastructure. And we also have support for SQL Server for doing data backups for what you're currently doing and producing data. Those enhanced features. And then we have users. We can create our users here. We can add users in, give them a username and a password. We can email them that details, and then we can also say to them, when you get your email details and you log on, you can do a reset so you can put your own password in. And we can create groups as well. And users and groups, we can give them all different levels of permission. If we look at our permissions tab here, you can see that we've got our users. I could individually, if I wanted to, drop a user in, but to save time, if we've got groups of users, I've created the groups and put the users in the groups, and now I can drop the groups in to the different sections of permission so you can see who does what. And we can take this down to the nth degree of what sort of level of permissions that you have for all the different people that log on. So that's quite a big improvement for the enhanced security. We've obviously got language support. You can edit your own languages as well, apart from the pre-programmed languages. If you want any changes, you can use the languages button to edit your languages. To also help with traceability, we have an events log. So this is recording everything that's done on the system. There's no actual test data here. This is everything that I've been doing, and you can see that I put an archive user one in there, deleted it, opened it. So it's everything, all the keystrokes. And each one of these columns here can be filtered using the various different filters that we supply on the top. Once a year, we archive this and let you get to the archive here, where we'll do it once a year on the first logon in the new year. And you can obviously export these to text files, emails, and print them. The attributes, the all tests, and the result tiles are like a repository for all the tests that you have. So it's a quick shortcut link. If you click on the all tests, I've just got one test in here at the moment, but it shows you what's in the test. And you can flick between these tests and see what each test is. We have a thing called batch sets. So if you're doing a lot of repeated testing, you can add one of these tests you've previously created to batch sets. And this will enable you to do lots of repetitive sets of samples in numbers of batches with exporting functionality. We have a specimen deflection compensation. It enables us, tends to be used for higher forces, small compressive loads, where we can measure deflection in the system, be it the fixtures, the load cell, and we can compensate in every test for that. But the most important one here, and Moses created a tension test, is we have a new test. So the first thing we need to do is give it a name. I'll call it the same as Moses did, and choose your equipment. We've got lots of different equipment, so the Omnitest range, the multi-test DVUs. If you're choosing things like a multi-test DV, then that will be the light version of the software. For all our Omnitest range is the full version, and all we need to do is choose our equipment and say OK, and then we're presented with our 3 different tests: tension, compression, or a bending test, and we just choose the one we want. Now, because we do materials testing within this, we offer the facilities so you can have stress and strain calculations as well, and the machine will calculate those and feed that out of data by applying the formulas to your load displacement to create your stress and strain. However, if you don't require all that data and you want to save some space on your computer, we also have custom. And if you click on custom, you can choose your axis that you want to display. You can also give it a new name if you want. And then we can put that. So now I'll be just generating data on a force versus extension graph. And we can add as many of these in as we want and choose what axis we want to do. We've got time, load, displacement, stress, strain, and speed. However, if we don't need that, we'll go back for the purpose of this to our default test axis, and we say OK. You can see it's very visual, and we just work through the tabs on the top to populate our text. You only need to do this once to set your test up. And here we have what's called attributes. And attributes are questions. This can be a text question. We can have images associated with the test itself. It could be a picture of your grips and fixtures, what your test sample should look like. So it's visual for the operators. We can put in things like sample ID, batch ID, lot number, anything that's relevant, which is going to tie that test to identifying the sample. And because I've already created a test in there, as soon as you create one, we add them to an existing attribute library, so they're there for all of the tests when you do it. If you want, you can just drop it in. This is just looking for our sample ID. Preferably, we would ask that question before the test. Operator would fill that in, it would be associated with the test. If you've got a limited amount of data for this, then you can go for a predefined value of lists and populate that list. And we can also do after the test, if it's observations that you're doing after the test. So these are the pre-test attributes that we can do pre and post test. We can put numbers in there as well. So if you want to actually work with a number like a weight or a temperature, you can use those in calculations later on. Next one is the specimen tab. And here you can put in your specimen geometry. We've got different shapes. We've got an applied area. But if you're putting in things like your width and your thickness, we're calculating area. If you know what the distance that you're measuring your sample over, your gauge length or your grip separation, you can also put those in there. We can have them as different values if we're using an extensometer. And if we are using an extensometer, then we can turn it on here, supporting both analog and digital extensometers. If these numbers here are an arbitrary number for the size of the sample, but you want to measure it with a micrometer or a vernier before the test to get a more accurate result, you turn on prompt the specimen, the operator will get this and be able to put the exact number in there before the test starts. We've got our standard SI units for the dimensions as well. And Moses looked at doing a break in there. Here we have a little break detector section. Threshold is when we turn it on. I'll put it at 1%, and that will be 1% of the value of the load cell we're using. But once it passes this level, it will turn the break detector on. It's very useful for like the test when you've got movement in the grips and fixtures at the beginning where you've got oscillation in the load and you don't want to detect a break at that point. And then again, we're just looking for a drop in force. So we can look for a 50% fall in force from what we were, our maximum that we were pulling during the test. Pre-test applies a small force to the sample beforehand, and if anyone's doing the ASTM tensile standards plastics, toe correction is a way of removing erroneous strain at the beginning of the test in accordance with the standard. So whereas Moses before, excuse me, he was typing in the code's individual lines, we've wrapped all this up now in a visual. So here on the settings page here, there you can apply your SDC if you set one up. And here you have all your SI units that we're going to use or we can use. And you can change your data rates here. And obviously you've got pounds, force, kilonewtons, all your standard SI units. We can put a shield on things if we want here. So if we were using a small grip with a large load cell and we were worried about damaging the grip, we could apply a force here on a shield and it would stop the test if it hit that value and protect the grip. We have a little bit of automation here. So if you're doing repetitive samples, we can prompt you just to keep starting the test again and again and again by turning this on and putting the delay in there, which is comfortable for you to swap the sample out. And the way we program this is we have a timeline which runs left to right. You can put up to 40 operations in there, and we have a toolbox to populate it. So we'll do the same test that Moses did. So the first thing we do is we'll drop a 0 in. So there's no programming to be done. So exactly the same as Moses do. And we're going to pull to break. So we have a pull to break icon. We just choose the speed that we want to do. And then at the end of the test, where do we want to go to? Well, we can go to home, which will be our home starting position here. And that's the test done. So there's no individual programming lines. We just drop the icon we want in there, and it's all done. So we have the common ones. So we have zeroing different features, extensometers, loads, displacements, pull to break at a standard rate, pull to break at a load rate. We have looping test where you can have a couple of commands and you can loop backwards and forwards for cycling. We have relative commands, which is basically making the machine go down, go up in force, or go down in force. And you can use any combinations of these. We have targets where you ask the machine to go to a specific value, i.e. a force value, a displacement, a stress or strain, force at a force rate. We have a couple of cycling tests between displacement and load. They're non-graphing, they are for scragging or preconditioning. We can also compress things to what we call percentage of absolute. We measure the sample and we can compress it by a percentage of its height or extend it by a percentage of length. We can put a pause in there for the operator. We might put a pause in here. We can type a message in the box and say, load the sample, and then press play when you're ready to start. If we don't want that, we can just drop it in the bin. Again, this is for the extensometer removal and measuring grip separation and a different part of the test. We can apply load limits, displacement limits, time limits, or digital I/O limits to anything that's happening in here. If we want to say, okay, we're pulling to brake, but we do not want our displacement to go over 5 millimeters, we can put a target before that, and it'll do both at the same time. It'll monitor this while doing this part of the test. And you can use load with displacement, displacement with load, time with anything, digital with anything. Conditions are what we call conditional jumps. And again, this is very similar that if we're monitoring something and we're looking for a change, let's say a change in displacement of 10 millimeters, then we can stop the test. Or we can jump to a different location in the timeline, and then it tells you where you're going to jump into number 4 when that condition is met. And we have those for load, displacement, stress and strain, time, change in digital signals. We have abort, we also have stop the test and abort the test. So those are the conditions. We've got digital outputs as well. So if you want to set digital lines on the stand, set them to 0. You can drop them in here. They're useful for automation purposes. You choose your digital line, and it'll set digital line output 8 to 0. And then you can also change that to a 1 or any other one at any point in the test. And finally, here we have the Vector Cloud Solutions, which is part of our unique feature that we have cloud sharing facilities, and this is really good for people who want to share tests and data. We'll have a brief look at that later. So I'll set my test up, and now I need some results. So I have my toolbox and my area here, and all I need to do is populate the results I want. So maybe the time I started, who did it, some information on my sample. There's my attributes. Maybe you want the test name in the report, your sample ID, and we just drop them in. We've got standard calculations. We've got lots here, and you can use these as many times as you want. Moses used a max on there, so we drop a max in, and we just edit it. You can call it whatever you want. It will report the first axis point on this. So if you're on load time, it will be time. If you're on displacement time, it will be max displacement. So we'll set that to, we'll call it max load. We'll set it to the load displacement axis, so it will look for the maximum load. You can hide it in the report. You can hide it in results if you are doing tests for other people and you want to have extra stuff for yourself rather than the main report. You can look between a range of 2 different points on the XY axis for that maximum. And as Moses said before, you could verify that we were looking for a pass-fail limit of between 10 and 20 newtons on that result. And because you can use these multiple times, if we put another max in there, and we set it up, we'll call this one displacement max load. We'll choose the same axis again, but this time we'll enable a different result. So this time we'll choose displacement. So we'll calculate the maximum load, but it will report displacement. And you can keep adding these in. There are lots of common ones in there, standard ones. We have specimen ones, which are things like Young's modulus and offset yields. We have some calculations for the metals test, ISO 6892. but you can use these for other types of testing. We've got friction, peel and tear testing, where we can calculate things, average forces, area by force, and it's quite comprehensive, and it allows you to pick different starting points where you're going to measure an average from. We also use this equipment for doing texture analysis for food. So we have a texture analysis section where you can look at parameters based on the graph which are related to texture. And if all fails, you could always throw in a formula where you could take any of your calculated results, apply an operator to them, divide them by, and if you put the sample width in, and call it a name, we'll call this one a question mark, so I don't know what it'll actually be, and apply your units, and now you've created your own formula. And if you want to reuse that formula again, it's there ready for you to go, and then you can do anything else you want to that as well. So we've set all our test results up. Our report templates are HTML reporting templates. So we have lots to choose from here. And if we choose one we want, I'll choose number 11. We can have a quick look at it, what it will give us. You can put your company logo in there just by selecting a logo. There we go. And then you can choose your axis that you want to report on. We can turn things on and off in this test if we want. And there we're just generating our results and our graphs. This is just test data, by the way. We can actually turn this off as well and just show whatever we want in the graph template itself. Once that's set up and it's saved, and we come out, it's done. If we're doing batch reporting, we've got templates for the batch reporting. And we had permissions on the front screen. We've also got permissions for this test. So we can edit what they can do, what the operators can do. The day shift might want to just sit a workspace and execute a test, but we might not want anyone deleting a sample. So when they log on, they will see a completely different view. And that's the test set up. We'll save our changes. And when we're ready to test, we click on the play button, and we have our graph. At the moment with stress strain, we can flip the axis to something else. And we press the play button. And once we've done that, then we're off and testing. So that was, I'll hand you back over to Moses, and he will take you through another test on Emperor. Sharon, could you start? Thank you.
Thank you, guys. I'm sorry to interrupt. I just want to let both Moses and Carl know that we're running quite late in terms of the webinar. So we either have to move very quickly through the other two tests or select just the most important one and do that, because
Absolutely.
we already have questions as well.
Yeah, now thanks Sharon, you're right. The 3-point bend and flexure test is very similar to a compression test. So since we've already gone through the preferences and everything in Emperor, I'll just go over a quick compression test, and then I'll toss it over to Carl, and he can just bring us home in VectorPro, if that's okay. I think that should pretty much help us save some time. All right. Okay, so if you can see my screen, we previously looked at what a simple tensile test looks like, as a force tensile test looks like in Emperor. We're now going to, and as you can see, it's a little bit more comprehensive in the new VectorPro test. And although this makes me want to quit right now, not want to do this, but this is what's actually worked for us in the last 20 years. Setting up a compression test is also very similarly easy in Emperor. So as always, with the 3-step process begins with the preferences. If you go into preferences, we're going to this time select compression as that initial direction of movement. Once again, select our preferred units of measurement. I'll select pounds of force and inches here, and this is all we're gonna do. I'll change our home position to 0. Now, there are also instances where now, as you know, in most compression tests, the test does not begin until the probe actually makes contact with the surface of the sample. So by entering in, say, a minus 0.25, a quarter-inch displacement as the home position, that means we ensure that at all times, the test will begin about a quarter of an inch above the sample. So that allows the operator to slide out tested samples and put in new samples and so on. And that's essentially all we're going to do here in the preferences. The next step is to configure the actual test. Again, could be an ASTM, could be an ISO test, could be an in-house test. As always, this time we're also going to start with zero load and displacement, append. We're going to clear data, append. And then we're going to do an initial run, which is our touch command. So we'll run at a relatively slow speed of 2 inches per minute, and we'll run to a very minimal force of about 1/4 pound. And that's essentially to allow the probe to touch the top of the sample without starting to compress it. That way we don't lose what the true displacement is in our test measurements. So we'll run at 2 inches to that preload or the touch force. And then one of the things I prefer to do is zero, clear data again, and we'll essentially do all of this again. However, this time, instead of running to a load, we will run to a compressive displacement. If you expect this sample to break, once again, you can put in that break percentage drop, and we'll update that. Then we're going to throw in the end command, which essentially completes the test. So all we're doing is run to a touch, zero everything out, run to a displacement, or at 5 inches or break, whichever comes first, return home. That essentially completes the test. And then the final step is to determine what kinds of data we're looking for. Once again, we're looking for a peak. We're going to call this a max compression for purposes of our test. Once again, we can run this through pass or fail criteria. And then there are also a couple of things that most compressive tests look for. If you take, for example, spring testing, there are times where you're looking for the force at a specific deflection, or you're looking at the displacement when a specific force is applied. So the value calculation allows you to do that. So we can say, for example, load we're compressing this to 5 inches. So I want to see the load at 2.5 inches. What was the force at 2.5 inches? And all I have to do is enter 2.5 in the value time, and that will return a load, which once again can be run through your pass or fail criteria. Bear with me here. Let's spell load correctly. This is being recorded. And then we're going to append that. Now, this time we can also look for a specific deflection when a certain amount of force is applied. So I'm just going to go back into that calculation. And this time I want to know the deflection at, let's say, 10 pounds of force. So all we have to do now is simply swap the X and Y axes and make Y displacement and X load, which changes that value field to force. It was previously inches, and now we can just enter 10, and this will return the deflection or displacement at 10 pounds. And we can just update that. I meant actually, sorry. Let's try this again. Well, update as in append will add another line, update will update the existing line. So we'll just call this load at 2.5 inches. Bear with me, change load, change displacement, enter 2.5, and then click append, and that gives me both calculations. Click OK. So now we have a simple compression test that would come down, touch on the surface of the sample, compress to a known displacement, give us the peak value, but then we can also query additional data like a load at a specific displacement or a deflection at a specific load. And that's essentially what a typical compression test looks like. And these can be used for, you know, all kinds of different samples, fertilizer pellets, springs, and so on. that's what that looks like in the Emperor software. And with that, I will turn it back over to Carl to bring us home. Over to you, Carl.
Thanks, Moses. You see my screen okay?
Yes.
Okay, so we'll do the same thing. I'll pick the same machine. I'll just give it a name for the test. Say okay, but this time we'll pick compression. We'll stick with all our graph axes. And we have the same setup again, where we can chuck in a sample ID. We've got our specimen if we want to do it. We've got our break detection we can set up. But this time in operations, there's something slightly different. So we're going to do a 0. We're going to do a touch on. So we just give it our touch on force and our touch on speed. Do we want to capture data? Not for this one, but we can turn it on and off individually for things. And then Moses went down and compressed it to a displacement. So we'll put in a target displacement. And we'll do a displacement of 50 millimeters at whatever speed we want. And when we've finished, we can come back to our beginning of the test. That's essentially set up now. If I want some results in there, standard results. Moses was talking about things, so we'll put some standard results in. Let's do a value. But let's do load at 10 millimeters. Choose our axis. X-axis in millimeters. 10. Occurrence number 1. I'm only going to get it the first time, and the result I want is the load. That one's done. I want to use it again. This time, I want the placement at 15 newtons. Change my axis. I can look on the Y. 15 newtons. Report the displacement. So we've done exactly the same thing. You've obviously got all your sample and attributes you can put in there. And that's basically the test setup that we're doing in Emperor. And one other thing I will say with the other test as well, you've also got your 3-point bending, which will have the same functionality, and also in operations, we've got the bending. This time we're applying flexural stress and flexural strain formula to all the load and displacement results to generate stress and strain data. So that is a slight difference of what we're doing with the bending test. One of the other things we've got in here, we'll look at a result. So I'll look at this one result here that we've got. You can view the result. This is where all your results will be put. If we go view the result, there's the test. You can see the test graph data. And there we can got our graph functions here. I'm looking at stress and strain, but if I wanted, I could look at any axis I wanted. And there's our results. So we're looking at area, tensile. We'll put some extra results in here. If you want to actually physically look at that result for that graph, it will show you. If you wanted to change any of these, you can by clicking outside, and it will take you back to the edit field. So if you've got existing data, you can actually change these and put in whatever you want. And there's some calculations that we've done for different types of nominal strain. So it's quite powerful. You've got statistics, which obviously the more you have in here, the better. But if you're looking at a graph and you want some quick calcs on here, you can do the same thing there. It's all very visual. So I think we've nearly finished on that now. So we'll go back to the presentation overview. And I think we're going to take some questions. I do have one more thing to show you before we do the questions. If any of you have got a smart device with a QR code reader, I created a test report earlier on. If I put this here, and that's a QR code that's generated from a test report. Now, you don't need VectorPro. If you've got a smart device, I'll give you a few seconds to have a look at that. If you scan that QR code, that should bring up VectorPro on your phone, tablet, whatever you have. And that's actually a fully interactive version of the test itself. And you can scroll through it. If you click on, I think it's the number 2 on there, that's the actual test. It will take you to the graph and show you exactly what's happening on there. I'll leave that up for another few seconds. Hopefully it'll give you something to take away from this and have a look at. Okay. Sharon, so over to you.
Thanks so much, Carl. So let me, there's a few questions already. So I'm going to start with the first one. Get to it. The first one says, and I just want to see, I think we've got about 5 questions to get through. So there was a known bug in Emperor when exporting data to a CSV file. If there was a measurement error, the data stopped being appended to the CSV file. Has this been rectified in the new vector system?
The answer to that is yes, we do it a completely different way in our interaction with Excel and CSV and datetime files. So all our data is stored in an SQL database. So we use the functionality of interrogating the raw data itself to generate the results in Excel and CSV. Okay.
Thank you. The next question, does VectorPro save timestamps down to the nearest second rather than the nearest minute in Emperor?
It'll do it to milliseconds if you need to. Yes, we keep 2 registers of what's happening. The system actually runs on UTC, Universal Time Constant, and then we also do local time from your PC. But yes, you can have it down to days, hours, minutes, seconds on your reports. Okay.
Okay. Next one, after finishing a test, can I change the unit or change the setting result?
I'm assuming they mean if I've done a test in newtons, can I look at it in pounds force? Yes, you can. If you go back and do the test results, you can then print a report off with your preferred SI units. It will revert back to its original. If you need to do it for a different SI unit, you can do that. Yep.
Thank you. Does this new software allow the addition of an extensiometer when tensile testing wire tensile?
Yes, it does. We support, if any of you are aware, we support all the range of epsilon extensometers at Epsilon Tech. This is their range of short travel, long travel. They have some specific ones for wire. If I just show you here in a test, all you need to do in a test. Can you see my screen?
Yes.
Yeah, okay. All you need to do is turn it on here. So once you've turned it on in the software, and it's both buttons on for the epsilon extensometers, if you're using the McMesin long travel MLTE, then analog is off. It's a digital encoder. And then what it will do is there's your gauge length of your sample. So if you're doing a wire test, you might have a gauge length of 250 mil. You might have a grip separation there of 300 where you hold it. And what it will do is it will now take the readings directly from the extensometer to generate your strain data. Okay.
The next question is, how do you go about setting it to absolute 0?
Okay. If you want to use an absolute 0 in here, the absolute 0 functions, view that in the graph, are here. in the graph itself, an absolute zero function will be permanent in the machine system. It will be through cycle through power rather. And if you want to set one on the machine system, I'm connected to a machine at the moment. If I wanted to make that my absolute zero position, I just click on the button. I can put an offset there if I want. I'm going to say you're at 0 millimeters. I can query where I am. I'm at 0 millimeters. And if I move my test stand away from that, so I'm a few units away, I could also come here and go confirm, and it's going back to 0 millimeters. So there's your absolute position is set there. It can be positive, negative, it can have an offset. And then when you're doing testing, we have some functionality. If you look in the operations here, if I was to do a target here, I could say move 100 millimeters at a speed relative to absolute. So we can move relative to absolute on that. And there is also at the bottom of here where we can move to a percentage of, we call it fractional displacement. So wherever you are when you start this operation, if you touch the top of a bottle or a piece of foam or something like that, you are 100% away from your absolute position. So if you compressed it by 50%, it would move from that position down 50% to your, or up 50% to your own intention to get to that percentage point there. Make sense?
Thanks, Carl. At the beginning, you have to indicate in the Vector software whether you want to test tension or compression. Why do you have to enter a sign, either a plus or a minus, in the program?
Not sure I understand that question.
Okay,
Can you
we
repeat
can.
it again?
I can. Otherwise, we can reach out to them directly via email.
Yeah.
But it said at the beginning you have to indicate in the VectorPro software whether you want to test tension or compression. Why do you have to enter a sign such as plus or minus in the program?
Ah, right, I'm with you. Okay, so if I was going in compression and I'm doing an operation here, so a relative command is move down or move up, and they're positive numbers. If I'm putting a target in there, let's say a target load can be positive or negative because it's going to a target. So I could already have force on the system at some point during the operation. If I asked it to go to 100 newtons at a speed, it would move to 100 newtons positive. If I asked it to go to minus 100 newtons, it will go down and go negative below that point. So we put signage on the text and stuff with compression when you're moving the system, because it's a target value. Your target might be below something or above something. If you're cycling through a zero force going positive and negative, we give you that ability in there. Hope that's what they were talking about.
Next question. If we can have a different layout of it, insert the number of the analysis done. I don't know if that's clear. I'll read it again. If we can have a different layout of it, insert the number of the analysis done.
No, I'm not sure.
Okay, we're going to move on to the next.
This came up in one of our discussions as to whether you can rearrange the tiles on the desktop, as far as the different test analysis or different test programs, whether you can kind of drag and drop them and rearrange the layout.
Okay.
If I understand the question, that's something that's currently in the works, I think.
Yes, that's we're releasing new versions of the software every 2 months. Yeah. I think there's a big one coming out at the end of this month, and that's in the development program to look at this workspace and allow you to group things in folders and stuff like that. So yeah, we have considered that, and we take feedback from people that goes into our development cycle, and a lot of the features that we have put in, apart from what we want to have in the software, is also customer feedback on what they require. So yes, that's coming.
Awesome. Next question. How to have a note section for sample information. Currently, it's lengthy.
Let's say that again, sorry.
Okay, I'm just reading it as it's it's written. So it's how to have a note section for sample information. Currently, it's lengthy.
It's lengthy.
Yes.
Well, the only note section we have, and we've got a default one here, I think it's 256 characters, where you can put, I tend to use this for putting information to describe what the test is doing for when somebody else opens the test. They don't know what it is. But for any additional information that you want to put with the test, you can add additional notes here by dragging a note in. And each time you get that amount of characters, if that's what they mean, not quite 100% sure on that.
Okay. And then I think we've come to the final question, and forgive me if I don't pronounce this correctly, but it is, can we measure Poisson ratio as per ASTM D638?
Poisson's ratio. Poisson's ratio is the ratio of the width of the sample compared to the elongation of the sample. Currently at the moment, no, because we need although we have the electronics can support up to 3 extensometer inputs, we need to enable that in the electronics so the software can read through it. But yes, that's also in the development cycle. So you'll be able to attach a transverse extensometer and an axle at the same time. And then you'll be able to do your Poisson's ratio, and we'll update the results and things files so that you'll be able to do that. You'll also be able to do S&N values as well. So the theory behind it is that if you're pulling something in tension, you initially give here in your specimen the width of the sample, but that changes as you elongate the sample. So the sample gets thinner, therefore the stress is more concentrated in that area because it's thinner. But the answer to that is yes, we will be addressing that in the future when we start adding multiple extensometry to the system.
Wonderful, thank you very much. And we've gone a little bit over time. There are some more questions coming in. So what we will do with the questions that we have received already is that we will reach out to you via email with some answers to those. And if need be, maybe set up a call. And I think that is us for today. Thank you so much for joining us for this webinar. If you have any further questions, I have put our email in the chat box, and it's showing on the screen at this stage as well. So please feel free to reach out to us and to ask the questions that you have both on Emperor and VectorPro, and we can see how we can assist you with that. But for now, thank you so much for joining us, and we hope to see you on one of our future webinars.
Thanks, everybody. Thanks, Carl.
Thanks very much, everyone.
Thank you, guys. Bye-bye.
Bye.
Bye.